Architectural designer. Art, nature, architecture. What is architectural sustainability? While the concept of architectural sustainability has gained recent popularity, it is essential to recognize that good architecture should always embody sustainability. To understand this, a historical perspective is necessary. Traditional and local architectural examples reveal how structures were built in harmony with climate, wind, and water, aligning with their surroundings. The resultant structures emerge as products of the symbiotic relationship and constructive agreement with nature. Integrating and aligning with nature signifies a core principle. Architectural techniques, material selection, and the reduction of CO emissions contribute to achieving sustainable architecture. Consequently, environmental factors that might appear constraining can be leveraged by architects as design criteria rather than problems to foster innovative and creative solutions. Architects face pivotal decisions regarding prioritizing economic sustainability, maintaining energy efficiency, ensuring the sustainability of human health impacts, and social sustainability. Thus, evolving the architect's approach within the design process to meet the demands of today is of paramount importance. In essence, why shouldn't a glass building be constructed in a particular region? What does the term intermediate space entail, and how can it be made more functional? What purpose does a courtyard serve? How can shading be effectively utilized? When does cross-ventilation prove effective? These are questions that architects should be able to answer. Consider a scenario where you're designing in a location heavily affected by wind patterns. Loading and unloading points become necessary. There are various design considerations that must be taken into account. For instance, you can't place them on the front facade. You need to leave substantial space behind. With the aid of experts and computer modeling, you can determine the necessary steps. Consequently, a building being 4 meters deeper or 60 centimeters taller than your initial plan significantly influences all wind movements in that area. Likewise, rotating a building by 15 or 30 degrees can drastically reduce cooling expenses. Advancements in technology are reshaping building envelopes. As lightweight structures incorporate more glass surfaces, challenges like noise, pollution, increased heating and cooling costs, and heightened energy consumption arise, resulting in climate change. Building physics, solar control, and decisions made in the early stages of design for thermal comfort play a role. Location, orientation, and climate-dependent design are becoming more critical. But why does climate change occur? The answer lies partly with the construction and architecture industry, which is responsible for 40% of this issue. However, it's never too late. Moving forward, architects must ask: what is the correct path? What is lacking? What needs to be done? How can I draw my clients into this perspective? What are we unaware of? And, most importantly, what can I do about it? Reducing the field of architecture to the notion of sustainability in a narrow sense would be limiting. It's worthwhile to envision this concept within a broader intellectual framework. Architectural sustainability. building a brighter future for all.